Alright guys, we're on our last lesson for chapter 10. This is going to be lesson 10-5, and we're going to talk about surface area of pyramids. Oh, there I go again. And today's date is going to be 5/6/19. Hope you guys had a good Cinco de Mayo. We had a good one. A lot of yummy food. So we're going to start by defining a new shape called a pyramid. So a pyramid is a three-dimensional, so like a prism, 3 dimensions, figure. But here comes the weird part. With only one base, that is a polygon, okay. At least 3, could be more, and here comes the weird word, triangular sides Now those are known also as lateral faces, lateral sides. So the faces are the flat parts that are on the sides of the shape. So our base is literally the bottom of our shape, and you'll see why in just a second as I add in the next bit. That meet, so these sides, at a point. And that point is called a vertex. So we got a pointy top and a flat bottom, okay? So we're going to talk about only 2 types of pyramids, and we're going to talk about very special pyramids. So the first one we're going to talk about is a square pyramid. So a square pyramid is a pyramid with a square base okay, which means it has 4 congruent sides, same shape, same size, and 4 congruent lateral faces. So that since the square has all the same lengths for each side, we're going to have also, these are triangles, the distance from those bases to that vertex point has got to be the same, okay? So the triangles are going to end up having the same area. Yeah, crazy, huh? All right, I'm pretty bad with these guys, so I apologize in advance for my drawings. Let's see if I can figure out how to do one. Yeah, that's as good as it gets. Sorry about that, gang. So again, here is our vertex. It's a point right there where they all meet. That's the vertex. We've got our base, which is at the bottom. That's our square base. And then this, from the vertex to the base of the square, bottom of the square side, and it's the same no matter where you look. Okay, he's got a special name. He's called a slant height, which kind of makes sense because it's a height, but it's on the sides that are slanted in to come to that point, okay? So slant height is the height of a lateral face, or side as we like to call it, okay? So let me draw you a net of a square pyramid. Okay. And from there you can see that all of my slant heights, they're going to be the same. All the bases are the same. Do a little tick mark for those. Boom, 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 boom. Okay. So if we want to talk about surface area of the square pyramid, we have the area of a square base plus 4 areas of congruent triangles. So technically, I only have 2 unique calculations I need to make. Okay? So I'm going to go to the next screen, and let's go ahead and do 2 examples of this. So our directions are going to say, find the surface area of each square pyramid. And let's see how well I can draw this. Not so bad. Okay. So what I'm going to be told is what are the dimensions of the base, and they're only going to need to show it to me twice. Why? Well, opposite sides are going to be congruent, right? Because look, it could be a rectangle, but that means 7, 7, 7, 7. Okay. In addition, they're going to have to give me a slant height, and they only need to give me 1, and they're going to label that this one is 9 centimeters. So we said we need to find for surface area the area of the square base plus I need to figure out 1 lateral area, so 1 triangular side, and then I'm going to get 4 that are identical. Okay? So my base is going to be a 7 by 7 plus 4 times area of a triangle is 1/2 the base, which is 7, times the height, in this case the slant height, which is the 9. And then we just start doing whatever math we can. 7 times 7 is 49. Now, a half can't go into 7 or 9 evenly, but I can multiply 4 by a half. So 2 goes into itself once and into 4 twice. And that leaves me with 2 times, and 7 times 9 is 63. So that gives me 49 plus, and then 2 times 63 is going to be 126. So I'm going to line those up and add them together. I get a 15, 6 and 1 is 7, 1. So I get 175. So the surface area is 175, and because it's area, it's square centimeters. Okay, let's do another one. Let's see, how can I draw this one? So we've got 16 feet by 16 feet, so we know it's a square. And then we're going to be given one slant height, because they're all going to be the same, so they only need to tell me it once. So we know what we're going to get. We're going to get the area of the square base, and we're going to get 3 triangular lateral faces that are exactly the same. So 1/2 the base, which is 16, times the slant height, which is 12. Okay, 3. Hello. I started thinking about the one I'm going to tell you in a minute. Preview. 4. Let's try that again, shall we? All right, let's start doing some math. I guess I can go. Let's do it like I did the other one. I started jumping my guns here. Yikes. I think I'm tired. There we go. Now we can start. So let's see. We have a 16 by 16 triangle or rectangle. All right. Go back. 16 by 16 square plus 4 times the area of the triangle, which is 1/2 the base of 16 times the slant height of 12. So I can multiply 16 by 16 off to the side, and I get 36. 6 and 3 is 9. Put in a placeholder. 1 times 6, 1 times 1. And I get 256. And now here, I think this time I will take half of 16, which is 8. And that's going to give me 4 times 8 times 12 is 96. So off to the side, 96 times 4, 24, 36 and 2 is 38. So I get 256 plus 384. And then I'm going to add 256 and 384. I get a 10, 13 and 1 is 14, 5 and 1 is 6. And I get 640. So the surface area is 640 square feet. Okay? All right, so let's get to the next shape. That is the triangular pyramid. Okay, so what makes a triangular pyramid a triangular pyramid? Well, remember that name triangular represents the base. We know what a pyramid is: flat bottom, pointed top, triangular sides. So what makes this one unique is that it's a pyramid with a triangular base and 3 lateral or let's do it this way. Let's say triangular lateral faces. So notice all triangles. Okay. Now there's 3 possibilities for what kind of triangle we could have as the base. We could have a scalene triangle, which that means all the sides are different measurements, which means all the triangles coming off of them would be different measurements. Yikes. It could be isosceles, where 2 of the sides have the same measurement, which means I would have 2 sides that have the same area, and then the 3rd side would have its own. Or, the best case, and the one we're going to study, the base could be an equilateral triangle. That means all the sides are congruent. That means all the lateral faces are going to be identical, okay? So let me write down that. Equilateral triangle. Just to remind you. three sides are congruent. Now, this is the only type of triangular pyramid we in 6th grade are going to study. You'll see in geometry class, you'll see every single kind that you can imagine. And I don't know, maybe even next year you might have to do more, okay? So what's going to be interesting is they have to give us 3 unique dimensions here. So when we look at our triangular pyramid, let me draw a picture of one. And believe it or not, I'm actually a little better at these because there's not as many sides to draw. Okay, so we have 3 triangular sides and the triangular base. So, the triangular base, and they're going to list all 3 of the sides. That way you know for sure it's an equilateral triangle. Then they have to give me the height of the base. Otherwise I couldn't figure out its area. And that's going to be 3.5 feet. Then they have to give me the height, the lateral height, so that I can figure out the area of the sides. And that one is 5 feet. So we've got 3 unique dimensions. We're going to have the base length. We're going to have the height of the base. And we're going to have the slant height. Of the, and I'm just going to use the word sides. So lateral faces, sides. Okay? So, oh, and by the way, if I drew this as a net, this one's actually kind of a cool one. So there's your base. And those are your 3 lateral sides. So I'm going to just kind of, there's your base, is the one colored in. So that's what that looks like. So let's do one example, and we'll carry on. We'll do this one. Find the surface area of the triangular pyramid. Okay. So I'm going to just kind of draw out what the triangles look like of this one here. Okay. And this is actually technically example 3. So we're going to start with our base. And we know it's 4 feet, 4 feet, 4 feet. And then we know that it has a height of 3.5 feet. Okay. And then we're going to get 3 more triangles. Now, all of them are peeling off of that base, so each one of them has a base of 4 feet, but each one of them is going to have a slant height of 5 feet. Seems so weird we keep using all these different languages, right? So crazy. And what you should notice, these are identical. So anytime I have anything identical, we can call things slightly differently, right? And off to the side here, I'm going to just label everything. So base length is equal to the 4 feet. The base height is the 3.5 feet. And the slant height is the 5 feet. Okay? So, we've got surface area is going to be the, let's see, maybe write that a little neater. This is your base, and we're going to get 3 areas of triangles that are the lateral faces. Okay, so remember triangles is 1/2 the base times the height. Well, the base of the base is 4, and the height of the base is that 3.5. And then we're going to have 3 lateral faces that are 1/2, and the base of each of them is 4, and the height of each of them is the 5. Okay, let's start doing some math. 1/2 of 4 is 2. 2 times 3.5 is 7. 1/2 of 4 is 2. And that gives me 3 times 2 times 5 is 10. So that gives me 7 plus 30, which gives me 37. And so we would say the surface area is 37, and this would be square feet. Okay? All right, we'll go over this again tomorrow in class. All right, have a good night.